All right, here's a homework help video for you on exponential functions. Okay, first one asks us to graph that function. Okay, that negative sign is in the B spot, and the B spot makes it reflect across the y-axis. So a normal function looks like that for 2 to the x or e to the x, whatever, sort of looks like that. So with that minus sign, it has to go like that. And then this plus 2 is in the D spot, and so it has to take this graph and move it up 2. So it's not this one or this one because they're not reflected over the y-axis. This one looks like it went down 2, but a positive 2 in the D spot tells it that it went up 2. All right, here's a good question to graph. We can probably graph it here in a bit, but we can probably answer the question fairly quick. This part down here, just looking at the transformations. Let me rewrite this in the proper form. So it should be 2 to that. We always put the x first. So I'm going to have minus x plus 1 down here. And then still I want to put that in brackets so I don't mess up what's happening. So let me just put it down here. F of x is equal to 2 to the negative, and then I'm going to factor a negative out of this and this. So it'll turn to be a positive x and a minus 1. Okay, plus 1. Okay, so now we should be good. So this thing here says it moves down, or not down, moves up 1, right? Up 1. So up 1, yeah, up 1, down 1. No, can't be this one. All right, we're down to 2. Okay, now this minus here tells me that the graph should go to the right one. Now I stopped the video because I'd done it right the first time, and then I looked at the answer and it says all of them say that they're moving to the left one, but that's incorrect. If you put this on a graph, it moves to the right one, and so all 3 of these were wrong because it's actually moving to the right one. And then the minus out front there is going to reflect it on the y-axis. So this one says reflect on the x, so it can't be that one. So the answer is that, but this really should be that it's moving to the right one. And maybe I didn't explore it enough, but I'm pretty sure I looked and tried a bunch of possibilities. But this down here is the correct way of writing it. And by that, this should move to the right. So to graph that, instead of a normal graph going like this graph is going to be reflect on the y-axis. So it has to go like this, then has to go to the right one. And so if it moves to the right one, maybe it'll be sort of like that. And then it has to go up 1. So it would probably finish something like that, just that ballpark. And you can try it in decimals just to see. Okay, next question says, suppose $89,000 is invested at that interest compounded quarterly, find the function, and then find a bunch of answers. Okay, so let's try it. So the function, I know the general function, they want to use A here, is P1 plus I over the rate, or I over N, to the NT. Sometimes I use I there, and sometimes I use R. I sort of use them interchangeably, interest or rate, but that I is looking for interest rate. Okay, so if they want to know what the function is, then I plug in everything I know except for t. So A of t is equal to the principal. They're putting in $89,000. And then 1 plus interest rate 3.5. So that'd be 0.035 over how many times a year? Compounded quarterly, so 4 times a year, to the, and then n is 4 again, times t. There we go. So there's the function, and now what they want you to do is plug in a bunch of numbers. So plug in 0, 2, 5, 10. I'll maybe just plug one of them in. Watch how easy it is to do in decimals, because what you can do is you can you can keep the same numbers there and just change one number if you want. Okay, so 89,000 bracket 1 plus 0.035 divided by 4, then go over, hit another bracket, to the, where's my to the button? Right there, and 4 times, let's do the 2 years one. So 4 times 2 is 8. You can just type an 8 in there. If you want to put 4 times 2, you want to put that in a bracket. So 4 times 2, bracket. Okay, so after 2 years, I started with 89,000. I'm already up to 95,000. Oops, 95,424 something. And they say round to the nearest dollar. That would be correct for that one. And then if you wanted to change any of the numbers, like if you wanted to do 10, all you have to do is get rid of that 2 and put in a 10. Oops, bam, there you've got your answer. So after 10 years, 126,104. Next question, similar kind of thing with this one. They give it to you in a table. All of them are in a table. Let's maybe try, I'll just show you how to do number 6, but they're all the same kind of thing. So it would be A is equal to the principal, 18,801, 1 plus the interest rate, 6.1%, 0.061. A lot of people forget that 0 in. Careful with that. Over compounded how many times a year? Daily. Oh, so 365 to the 365 times, they're going for 3 years. Okay, again in decimals, you probably want that in brackets. Let's try it. Oh, my decimals isn't working. I love this because you can just, oh, that's why it wasn't able to be active. There we go. Okay, so 18,801 bracket 1 plus 0.061 divided by 365. It'd be great to have interest that was compounded daily. To the, in brackets, 365 times 3, bracket. There we go. 22,576. And they say, do not round off your final answer. Oh, round to 2 decimal places. Oh, until the final answer, round to 2 decimal places. So I'd be calling for this one, I'd be saying 22,576 to 2 decimal places, 0.17. 0.17. Okay, notice how nice decimals is because it sets it up exactly how the formula has it. Sometimes on a graphing calculator, scientific calculator, it doesn't look the same and you're not exactly sure if you have it right or not. All right, next question, similar kind of thing. So here's the formula, and they say T is 0 is 2006. So they say how many outlets in 2008, so that's 2 years after that. So T would be equal to 2. So you'd plug in your numbers. A of 2 is equal to 228, 2.32 to the 2. Figure that out on your calculator. 2010 would be 4 years. 2011, what's that? 5 years. Okay, so you just plug them in. I'm not going to plug them in. You can do that. Next question, same kind of thing. T is the number of years after 2014. So if they want to know in 2019, you'd plug in 5 for T. So T would be equal to 5. Okay, same kind of thing. Years correspond to 1997. So how many in 1998? So your year or your t would be equal to 1. Okay, same kind of thing. This one looks a little funner. There's more stuff involved in there. So they say what percentage after 30 days. So 30 is your t. 30 gets plugged in for your t. Let's just use that in Desmos and see how much fun we can get into here. Oops. Okay, so let's plug our numbers in. 100. Oh, I can't see my stuff. How many years are we doing? 30 or 30 days. Okay, now you can see numbers. So 100 bracket 1 minus. Notice it's in a funny order there. So it'd be tough on that one to do transformations because you've got a binomial inside the bracket. And usually for exponential, there's just one, but we don't have to worry about transformations here. Okay, 1 minus e to the, in brackets, negative 0.03, and then times t was 30. 30, there we go. So they're wanting to know what percent of the market gets sees or buys a game, whatever. What percent of the target market predicted? In this case, it'd be 59.34. Round to the nearest hundredth, that's what I did, 59.34. All right, hopefully that helped you with that section for homework. Notice how useful Desmos is in calculating answers and helping you type them in the right way. Lots of students have found in the past their only mistake is plugging it into the calculator wrong. They do all the work right, it's just the calculator doesn't work right. Desmos is a useful tool.